biggest issue I was having is vibration. This is just, it needs support, I'm realizing now, and I don't have any sort of steady rest or anything like that. Okay, so here's an overview of the parts you're going to need for this project. I'm not going to give specifics as of yet. We have to make this, and then I'll see if my sizes chosen are going to work correctly. And in the description below, I will have a list of everything that's here. The most important aspect to this whole project are these wheels themselves. Now these are ones I already had. They're for a different project. I'm going to use them for prototyping, but what I would recommend is the ones you want to get are called indoor wheels. These are referred to as outdoor wheels, and the difference being a harder compound. Now there is talk of concern I've seen on when you're making steady rests that the wheels themselves can leave marks on the workpiece. So my opinion is, well, if you get the softer compound wheels, which are the indoor wheels, then that should help minimize any chance of marking. Now, they actually have a hardness rating on these wheels, and when you look them up, you'll see that. And I believe the softest you can get, it's called a 74A. And many times when you find those indoor wheels, they'll call them extra soft. So I myself am going to be ordering the extra soft 74A. These are 76 millimeter wheels. Now the extra tip I would say when you're looking for wheels, go to eBay. eBay I find has some of the best pricing on these. Generally, you won't pay more than $20. It'll include a set of bearings for your wheels and free shipping. Now these wheels are available pretty much anywhere. Any skate shop, I'm pretty sure even Walmart might have them. What I would say is stay away from used wheels because they might have nicks or chips and things like that could interfere with the spinning of your workpiece. You want these wheels clean and smooth because you don't want anything that could actually induce a vibration by the wheel having marks. Okay, so let's go over the remaining items. One of the things you're going to need for this project are some knobs. Now these I already had from other projects or experiments. So you're going to need one knob that's to tighten it to the lathe bed, and then these other two are what tighten the arms in position that hold the wheels. If you don't have your own, you can get wing nuts and that would work. Because one thing I will say is for the lathe bed itself, you may want that one to be some substantial knob because that's where we're going to position the jig and then tighten it down on the lathe bed. So you're going to need some good torquing ability on that. Okay, so let's talk about some of the hardware we're going to need. You're going to need a total of 3 different 1/4 20 bolts. Like I said, I'm not going to give you these specific sizes yet. The description below will have all of the sizes I use. Since it's a prototype, some of this might change as I'm putting it together. But obviously a long one is for the lathe bed. These two hold the arms to the base. The final 2 bolts we will have are basically the axles for the skate wheels. And in this case, they're 5/16 bolts. Those are a pretty perfect size for holding these kind of wheels on. The other thing we're definitely going to need is some T-nuts. Now, I like using these over the threaded inserts because threaded inserts tend to coming undone sometimes. Because when you put them in one way, it's great, but then when you back them out, sometimes you pull them right out. So I find prong T-nuts work the best. And then for those axles, you're going to need some 5/16, what they call it, nylock nuts, and then some 5/16 washers. Now, when you get the washers, try to make the smallest washers you can get with the smallest inner diameter as well. One thing that's worth noting about when you buy these 5/16 bolts as an axle is the center ring that rotates is actually just a little bit proud of the surface that doesn't move. What's great about that is when you put the bolt in, you don't have to worry about it grinding or anything like that. I just still like to put those washers on and it raises a little bit higher. That will help because this is a wood project. There's going to be lots of dust around. So by having this bigger washer on here will help hopefully keep some dust from getting jammed into that bearing. Okay, and the final thing is sort of a let's just get by for prototyping. I just so happen to have some fender washers that combined are the perfect size. What I did to determine how to mount this to the lathe bed is I pulled off the tailstock of my lathe. And I noticed underneath it, it's basically just, looks like 2 different washers that have been welded together. And it just so happens as these 2 are the exact sizes that this size here, which I'm not even sure what the size is. Like I said, it'll be in the description below. This size fits between the groove in the lathe bed, and then this is just wide enough to not go up through that center. So you've got the same sort of mechanism that's already built into that lathe. So I'm pretty much copying what they already have. My plan is, if this works, is either get some thicker steel or make my own that will do the same thing as what the factory tailstock does. Okay, and now finally the wood. This project should easily be done by scraps that you just have lying around the shop. Now I'm going to recommend strictly doing this with plywood, just for the sake of rigidity. You don't want any sort of warping or anything going on, but I think plywood would be best for this. Now, if you don't want to use plywood, you just want to use standard wood, all you're gonna need is a 1x3 that's 24 inches long. And actually that's even longer than you need. I think you only need 19 or 21 inches. But there's one aspect to this jig that you may want to make the piece of wood longer. So by getting a 24-inch piece, and you'll cut that piece last. That's how I have it set up on my cut list. It's the last piece you would cut. So that way you don't have to make it the length it's supposed to be. I would just cut the width and then leave the length alone until you're done making this jig. So let's get building. Okay, so we got our pieces cut, got our side rails. Let's see, this is the bigger one. I believe this is the base. This is the riser. And then these are the arms. Now what I did is I cut a couple additional pieces. These aren't the right length. I need to shorten them. But what I realized is I'm looking at this, and 3/4 inch just looks a little too small. Well, this piece, I was using some horrible plywood. You can see there's these big gaps in there, so I'll try them out at 3/4, because all of these measurements are based on 3/4 inch stock. However, when I'm looking at it, I think 1 inch would be fine as well. It really won't affect anything. It just, you know, the measurements on where to drill holes, if anybody were to follow it, they'd be off. Everything would be off 1/8 of an inch. So I'm going to go ahead and save those, but I will also make them as I'm putting this together. First thing we're going to need to do is on the base, we do need a notch right here, because these pieces actually fit down lower. I feel that's going to give a little bit more stability if it's here. So here's what I'm considering the most crucial part of this whole build. To completely disregard all my measurements, since everything was not precise, now this will give you absolute precision. Once you've got, like I have here, it all mocked up, I've got it clamped together. What we're going to do is I have the spur center that came with my lathe, and it's got a center point. So we clamp this together, we're going to go right up to that point and just kind of scrape on there. And what that's going to provide for us is now we have an 100% accurate representation of where the actual point of the lathe is. Because all of my measurements are based off of this fictitious number. So this way now we can draw a line, we'll have a reference, and then when we start making holes, this is what I was referencing everything off. Well, now you have a true reference. To reiterate about this starting point, I went ahead and darkened it in with pencil, that little scrape that I made. So now we have a true reference line since all of my measurements were based off of this assumption. So now we can use that. I'll mark this up. I'll mock up where all the holes are going to be. What I will probably do is stop at that point and then go to the arms, since another issue I had in order to make everything nice and square is the spacing of the wheels. So I need to get the wheels mounted onto the arms, and then we can set them up to here, and I can check all my measurements and see how accurate they are if anything needs to be adjusted. Since, like I mentioned, I don't like these 3/4 just looking at them, so I'm going to drill them, get them processed, and at the same time I will be doing the 1-inch bars and seeing if I like that better. But if you do the 1-inch bars, then the entire thing is off by 1/2 inch. So okay, being that I'm an absolute perfectionist, I was not happy how this one turned out on the bandsaw. I don't know what I was thinking when I decided I wanted to cut a slot using the bandsaw. It didn't give me the precision I was after. So I thought about using my box joint jig, which I always want an excuse to use that thing. So I did it on there, and now the results, I am much happier. Tolerances are exactly where I want them to be, so, and it fits perfectly. Okay, well, obviously next steps are getting some holes drilled. Okay, well that was embarrassing. T-nuts don't go in here. That's just for washers. But of course, I don't know what I was thinking. T-nuts go in the knobs. So. Okay, so all of the arms have been drilled. I've softened the edges, rounded the corners. Now we have to cut a slot. That's going to be the biggest challenge, and there's many ways you could do this. I'm going to use the router is what the best way I'm thinking of doing it. Then I get a nice, very clean slot. You could use it on a scroll saw, would probably be another good option as well. And I may do one of these on the scroll saw just to give you an example. Now setting it up is going to be a bit of a challenge on the router table as well. So let's see which way works the best. Okay, all of the pieces have been drilled, the edges have been softened. One thing I have changed is I'm using 1-inch arms now instead of the 3/4 inch. And fortunately my measurements didn't have to be changed. Like I was concerned this angle, and when that piece was on here it was going to be too close. No, it fits perfectly as if it was meant to be. Another issue I was noticing is the clamping mechanism works great, however it's hard to keep the bolt underneath from spinning. So I need to figure out a way to make more of a captive system so that when turning the knob, whatever's below won't rotate. So that'll be in the future. For now, I'm going to get this assembled. We're going to put the main panels together first, which I'm going to glue this up, get that clamped, and then once the glue is done, I'm probably going to drill holes through here and either run dowels all the way through or make the screw go all the way into here, but I don't know if I have long enough screws. I'm thinking of gluing some strips of sandpaper to this back part. The other issue I was noticing is when you put the arm on, that weight is heavy enough that it puts quite a bit of load that it isn't too difficult to move this. So my thought is that, well, if I put some sandpaper, hopefully that will provide enough grip that it won't rotate. And I did a little bit of testing and that did work. Another point I should make when it comes to getting these 5/16 inch bolts, it turned out I needed a longer one, so I have a 2.5 here. Actually, you need a 2 1/4. They don't make 2 1/4, so you get 2.5. However, when you pass 2 inches, they start adding a smooth shaft. So you have to go to a special bin that they have. At least at Lowe's, they had it in a specialty bin, and it was all thread style bolts. And the reason why I want you to have all thread for these wheels is because these threads, they just fit through the center of the bearing, and then you really don't have any kind of play this direction. However, if you had a smooth shaft, you would have a lot more play. Even if it's tight, it's still going to be wobbling. In the beginning of the video, I stressed about the size and hardness of the wheels you should get. Well, I've kind of backtracked a little bit. When I put this together, originally I was going to put the wheels on the outside of this arm. Then I realized they fit perfect on the inside, and I kind of feel, I don't know if this really make a difference, but if the wheels are on the inside, they're almost perfectly centered. They're a little bit, versus when they're over here, they're completely to the side, and I feel like that's going to add a little bit of like torque to the outside because it's kind of unbalanced. Towards the center, you're more straight down force rather than sideways force. Now, that's all great and that works perfect. You can mount them either way. Now, with this adjustability, if you go all the way in when it's in the center, it actually will just barely touch right here. And then I'm realizing, well, there's no need to have to change the wood or any of that stuff. You just don't go all the way in. But if you want to make it foolproof, I'm realizing if I got the 72mm and I have this thing all the way in, it still won't touch. Yeah, the whole reason of using these nylocks instead of, say, jam nuts, you could use 2 nuts and have a jam nut setup. However, with the nylocks, you're not dependent upon the nut being pressing against a surface to hold it tight, like a clamp. This will allow us to micro adjust the precise amount of tightness we want so that this wheel can spin freely, but not have too much wobble. Like if this bolt were to push through, you have the chance of the wheel going like this, and this is what we want to eliminate. We want this to be perfectly true with, if possible, 0 side to side motion. Okay, so there you have it. As you probably noticed in the video, I've already found several issues with this. Not so much in the design itself, it's just I was having trouble with tightening in order to keep the bolts from spinning. I have an idea how I can fix this bottom one. And I do have a couple ideas up here. One idea was to simply epoxy the bolt and that washer in place. That would do it. And I know a lot of people say, oh, just use carriage bolts. Well, yes, you could use carriage bolts. My issue with carriage bolts is they slowly waller out the hole, so it wouldn't be what I would consider a long-term fix. I definitely could just take and put some of those in now, but like I said, I don't think they would last very long. And I think that was about it. It still might be true what I was saying about the wheels. I seem to be having a hard time even still with a little bit of vibration. It wasn't 100% solved. I was able to do what I wanted to do, and I wasn't getting those infamous little, I don't know what you call them, but when you have vibration and your tool is chattering on there, you'll get these little like spirally kind of grooves. Now that wasn't per se happening, but you could hear the screeching that was going on, and I was trying to take the lightest cuts possible. And I even tried a different carbide tool of mine in case maybe it was the carbide cutter itself was somehow getting dull. I even tried putting it at an angle to do more of a shearing than a scraping. Still was getting a chattering. So then my other idea is, I think it might also be that wood, because I noticed that that wood was a little bit difficult to turn. It was cherry. I still hold true to my statement about the wheels, and I've got some on order that it's also possible that because you're so hard, they're not really absorbing the vibration. They're just rebounding the vibration, if you will. So when we get those extra soft wheels, we'll see if maybe then we get a little better result. And I'm going to try a different wood species. Instead of cherry, maybe I'll try walnut next time. So I will make a follow-up video of any changes I've made and the results of those changes. So until next time, you take care.